So this is a special circuit that we're going to be using here. Obviously, if we're representing all numbers and all letters and everything through just zeros and ones, then we're going to have some method of doing some form of mathematics on them at some stage. And so this is what we refer to as a half adder. This is 2 bits. This is simply either the number 0 or 1. And we want to be able to add these together. So let's say at the moment it's 0 plus 0. When we add them together, we get this answer of 0. If one of them becomes 1, that becomes the question 1 plus 0, and the answer is 1. And either of them going to that 1 gives us that there. It's only referred to as a half adder because it doesn't completely handle the type of addition that we'd need to do if we're doing bigger numbers than just 0 or 1. And let me show you that as an example here is if both of these switches become 1, so 1 plus 1, we know the answer is 2. And so in binary, what that actually does is it makes this become here a 0, and 1 gets carried on. And then if you know much about binary, 1 plus 1 is actually equal to 2. This is actually representing it, but you just probably need to put your head on your left to lean it to the left. This is the ones column, and this is the next one. And what we're actually able to do is join these half adders together to turn into what we call a full adder, and that then helps us to do maths on this. But simply adding 2 ones together plus potentially another one from a previous question. And we'll show you how to do that in a little bit later on. So the challenge from the book is how could we also create a half adder using some other pieces of circuitry? So it says that you can do it with an exclusive OR and an AND. And so just as we look at that, let's think about how we could actually build this together. So if I join that to there, and I join this one to here, and join that up to, let's just bring that one up here, click that one, and join that up like that. So now if I've got this here, the exclusive OR is very helpful because as I move both of them on, it turns to 0. But if one of them is on, it's off, and that's exactly what we're after before. So now the challenge is to wire up this part as well, and see if that will give me the carry. And the only time that the carry will happen is when both of them are on and the exclusive OR is off. And so now my sum and my carry can be achieved by just using 2 pieces of circuitry. The exclusive OR for the sum and then the AND for the carry.